everyone. How are we doing? There we go. Let me see right here. I feel like a mirror image for some reason, but how is everyone doing? Let me see right here. Getting everything situated. We're live. Cassandra, good to see you here. Abigail, good to see you here. I just feel like some days I feel like the lighting has changed or my audio levels have changed. Maybe that's it. Oh, you know what it is? No, the Go XLR is on. I don't know. You never know. You never know. Mic monitor. Oh, there we go. Let's raise that up. I don't know. We'll figure it out. Can't tell. It's the audio on the computer. Well, maybe I'm going deaf. But how is everyone doing right here? Abigail, good to see you here. I feel like the audio's clipping. If the audio's too loud, let me know. I need to go review this later. There we go. Good audio level right there, maybe. But who's in the chat? Feel free to say hi. I might try to do some fixing of things. There we go. And YouTube, OBS, fixed lag. I was trying to figure out how to fix any sort of lag issues on OBS. But if you have questions in the chat, let me know. It's office hours, and we're just hanging out at the moment. Hello, I had one question I've been confused on. How do you use the log transformation? Awesome stuff. Is this for, Robbie, is this for the current assignment right here, the BAS 320 current assignment? I believe so, right? Let me get that pulled up. We can take a look at that. Assignment 6, right? Assignment 6 with the log, and I think it's a log 10 transformation, right? So we're going to take a look at that right here. Put a little music on, get that started up. Get our notepad out. I think the headphones are... There we go, it's the headphones, I think, yeah. I put them in my ears slightly, there we go. It's like driving me crazy, I can like barely hear it. And I'm like, what's wrong? Why am I not hearing things properly? So much. Okay, let's do BAS 320, assignment 6, log transformations. Okay. When you know when to use them? Okay, well, yeah, we'll talk about using them a little bit here and when to use them. So let's go ahead and jump into that. Here we go, log transformations and how to use them. So when it comes to the log transformation is going to bring in extreme values. So if you have extreme values, and what do I mean by extreme values? I mean things that are very far away from the rest of the data. And we have a data set. Here's where we go. That's 95% confidence prediction intervals. And here we are with the data set we're doing. This is Q2A. And let's load in the data EX3. Ooh, we don't have library reg class going. And let's go data is EX3 housing. There it is. Now, when you originally look at a data set, you want to see if it needs transformations. And this data set right here, we're going to make a linear model just for the time being of price. I think it's capital price. We'll take a look over here. It's capital price. And this is the Y variable of interest. Price tilde area. Data equals EX3 housing. So that makes a linear model of the Y variable price with the X variable area. And then we have the data set we're using is the housing data set. First thing I would do is I'd visualize this. Now the problem is that there are some very high values of homes. And what do you notice right here, Robbie, with this data? Like there's some big issues with it immediately I see. So Stat 201 should also know this. We were just covering this with chapter 8. So if you're watching and you're from Stat 201, there should be a word that goes through your head right now. There we go. Decrease font size. I don't want to do it. There we go. Perfect. What do you notice right here, Robbie? What is going on with this? Let's throw out 100 points just to start right here. What do you notice is going on with this data right here? What is going on with this data? What problems does it have? What's weird about it? What is going on with this data? There's some pretty major issues. I would say this data has a major this issue. And so what do you think about it? And maybe we could fix this. And I'll tell you the number one way to fix it. Like we can try, as it says, to do I think it's a log 10 transformation. We can do the log 10 transformation, which this problem walks you through, but we can also look at some of the issues with it and see what's going on. So what do you think is going on with this data? It fans out. There, 100 points are there. Great job, Abigail. It fans out. That is heteroscedasticity or plot thickening. Well, so the lines, this won't be the normality. Good answers right there. This is the confidence interval for the mean of the line, and these are the prediction intervals for the individual points. So if we want to look at the normality of it, we can run a check regression to see if it has issues. And on the check regression on the model, we see that there are problems. Now, this is where there's problems with normality, and that's a big problem with normality. And then we see the fanning out that Abigail mentioned right there. So we could check the problems with normality, which would be right here. So this is the QQ plot for normality. This is not a QQ plot for normality, which QQ plots do kind of make a similar thing with the line and all that. But this is an actual like regression plot within a y and x variable, where a QQ plot tells us what we would expect via normality. It was behind me right here. And this is given its normal, and this is what we observe right here. So if we follow the red line, we're observing what is expected via normality, but we're outside of the bands. So we're like, this is not normal. It's due to these high values up here, which translate to these over here. We're seeing extreme values. So there's a bunch of outliers. There's a bunch of fanning out, and we fail every condition. Big problem with the unequal spread right here. So that's a big problem on this graphic. And then the normality of residuals. I don't see a linearity issue. The line looks to go through the center, and that specifically on the linearity, even though it fails, it's good to point out it fails, but it does seem to slice through the middle of it. Think of this as a slice of pizza right here, and it's cutting through the middle of the pizza. And that's what this line is doing right here, is it's cutting through the middle of this pizza slice. Like this is your pizza slice, in case you can't see it. People won't be like, pizza slice? What are you talking about? We're saying pizza slice because it kind of fans out. So there's your slice of pizza right here. And then you're asking, I don't know. Maybe I didn't draw my pizza slice properly. This time it's a slice of pizza. And then you're asking, does this cut the slice of pizza evenly? Does that cut down the middle of it? And to a certain extent, yes. The bigger problem is the fanning out. And also we see here the extreme values that are pretty far away. So there's a fanning out and extreme values. And so that's pretty bad. So then the question becomes, and this goes to Robbie, your original question, is when do we use transformations? Why would we use transformations? Transformations might try to what these issues. Think of a 3-letter word that a transformation might help what these issues. So think of a 3-letter word with 100 points right here. It's got to have 3 letters for 100 points. A transformation might in some way what these issues. And that's why we would do transformations. So like why transformations? Well, it might what these issues to a certain extent. And it could also help R squared. But a transformation might what these issues. 3-letter words. 3-letter word, a transformation might, to a certain extent, what these issues. Maybe not 100%. We'll see what it does. A transformation might what these issues. 3-letter word. What do you think? Think of a word like help out. It could, like you go to the sink and it's leaking and you're like, I need to what this sink. Like we've got a leaky sink right now. This is our leaky sink. We need to what it. 3-letter word. We need to do what to this leaky sink right here? We got to take out the tools to it. We got transformation tool. We're going to work on it. We're going to try to what the leaky sink right here. Fix it. Abigail, 100 points right there. So it's going to help with some of this. Great job, Robbie, too. It's going to try to like fix some of these issues. It's going to help the R squared. So we're going to run the code right here, find transformations. And with the find transformations, we have a capital M model. Really? I had caps lock on. What do you notice about the highest R squared transformation? What do you notice between this data and this data here? So I want you to see this is the one with the highest R squared, and look at it here and then look at it here. There's a big difference in the new one has a much better what of the data. And if you look at the change of R squared, we go from 67% to 74-ish percent, 73.6. But this one right here, which is the highest R squared, looks to have a much better what relationship. Like, what do you think we fixed? Normality of residuals might still be bad. Linearity might still be bad, even though that looks very linear to me. Put a line through that, it goes through the center of that data. But the big thing that I think we fixed going from the no transformation, which is what we originally saw, this was our original data right there. And then here's our highest R squared. It does show subsequent lower R squareds. But if we were doing this on our own, we'd be interested probably in the highest R squared to say, okay, the best set of transformations is the 3/4 power, the negative 3/4 power for some reason. Who knows why? It goes through a vector of transformations and finds the one that optimizes R squared. And hopefully that would create a relationship where there's not outliers or heteroscedasticity. But what does this look to have fixed going from the original, which is what we were looking at just moments ago, to the now with the transformation? What does this look to fix? Who knows? We'll see. Another 100 points in the chat right here. I would say it looks to have fixed this. It's like, yeah, it's way better on that. It's doing a good job. we say, hey, you're doing pretty good. Visually, I'm fine with it right there. It's probably going to fail it. A lot of things fail. But visually, I would say what on that? We'll see. We'll give it a second right here. Little chill music. What do people think? I would say going from here to here, there's a marked improvement in the unequal spread, the plot thickening. So here you see plot thickening, and here you see a relative same thickness. Like it's pretty good. Like maybe there's some issue that I'm not really seeing by not looking at it closely enough, but overall that top right plot looks to have similar thickness throughout, about similar thickness, as opposed to this one that starts off very thin and gets thicker, and we don't want an unequal spread. We want it to have the same spread throughout. And we're most interested in the best R squared if we're doing this outside of like doing it in class. So you might say, well, why are we doing log 10? Log 10 has a certain property that we like. Log 10 is a very nice transformation to use because if I ask you to take log 10 of 1,000, what is log 10 of 1,000? There's a quick trick you could teach kids and they'd be like, I can log 10 any number if it's a multiple of 10. You'd be like, oh, well, it's got a trick to it. What is log 10? What is log 10 of 1,000? Does anyone know that off the top of their head? You can use R to cheat. But what is log 10 of 1,000? What is log 10 of 1,000? It'd be 3. And then log 10 of 10,000 is 4. And log 10 of 100,000 is 5. To do log 10, you just, at least if it's set up like this, you just have to count the zeros. So log 10 of a million is 6 because it's just one more zero. So it's what power do you raise 10 to get that number? 10 to the 6 is a million. So you just have to reverse engineer how it's found. Now, we don't always log 10 pretty numbers, but we can understand that it's like decreasing the power it's raised to by a factor of 10. So what power do you raise 10 to get that number? Something like 1.2. If it's been log 10 would be probably like 32. So if we go here and raise this to 1.2, 15, and then if you go here to log 10 of this, oops, that'd be 1.2. So you can see like the reverse of it where this value right here, it just undoes like the 10 raised to. And that's going to be important for writing the equations later on. So the whole point is understanding what a log 10 does. It's going to bring in extreme values. Like this sequence of numbers right here would be 3, 4, 5, 6, even though they're huge factors away. Like what's the difference between 1,000 and a million? A difference of $999,000. And what's the difference when we do the log 10? It's difference from 3 to 6, which is 3. So very, very big difference right there. Huge differences. With that in mind, what we want to do, especially for this problem, is we want to go log 10 of EX3, and price is the Y. And we're just doing it to a vector now. So instead of doing it to 1, we're just doing it for a vector. So you can see the prices are somewhere between, that's 100,000 to a million. Makes sense that most houses are over 100,000. So this is like 5 to 6 log 10 is between 100,000 to a million. Area on a home is somewhere the 3 zeros, so it has to be more than 1,000 square feet. Under 1,000 square feet is a rather small home. Even my apartment's a little more than 1,000, like 1,020. But you can see here, I wonder what the min is. I'll go to min. Is there a home under 1,000 square feet? Yeah, there is. And if you went and looked at this, that's going to be like 990 square feet or so, 980. So having this understanding of what it's doing is important. Like we're changing these values to be closer together because maybe there's a better way to build a model based on transformed values. Is this making sense, Robbie, right here? Like we've got these values that are all spread out that might violate conditions, and then we're going to transform them into something that might actually make a better linear model. The whole goal for this is to make a better model, to explain the data better. And the fine transformations makes that clear when you run it by showing you the values of R squared, by saying, originally your data has this R squared, and that's the way the data looked originally. And now your data, if you use this set of transformations on it, will have this R squared. Now we're going outside the bounds of this a little bit, and we're saying, how about we make a Y variable that is this? I'm just going to call it Y for the moment, an X variable that is this, And then let's build our model based on these variables. And there we go. So now we've got it y tilde x, and I just stored it as y, not y transformed, and x, just x regular. So we've built a linear model. And let's look at the summary of it. Remember, we had about 68% before the transformation, and now 67%, I should say. Not the y. And now we have 72.6%. And if we look at our model right here, remember we had the heteroscedastic nature beforehand. Now we have a little better. Oh, look at the residuals. Where's my other model? Oh, Neostoria says M. Okay, so here is, let's take a look. I think this might make it a lot more sense. Okay, here's my original model, and here's my new model. Does the normality of residuals look better, Robbie? Yes or no? What do you think right here? Does the normality of the residuals look better? Yes or no? So here's the original. And here's the new one. Like, look at that right there. And then only a little bit. Versus this down here. What are your thoughts on the normality of residuals? Yeah, that's way better. 100 points, Robbie, right there. That's way better. This is the original with points starting off just deviating very much outside there. And then down here on the QQ plot for normality, it's like, yeah, those residuals are not normal. But in this one, like, I might actually let that pass. Like, we see stuff good, bad. Why is my lighting going crazy? Is it over there? Kayla pointed out yesterday. I don't understand. I need to dim it? Is it too bright? Apparently it is. Just try one of the two things, like dim it, brighten it. I don't know. Why would it just midstream start doing craziness? You never know. But yeah, she said it was distracting, so I want to make it as good as possible. Yeah, so that's got it right there. This is why we do those things, why we change things, and why we try to make things look better. I feel like... What are you thinking, Robbie? Let me know if you have any questions. Look at that. Trying to fix lighting here. So we do this. That looks better. There we go. We got so many controls and everything right here. I'm just going to hit every button. What questions do you have, Robbie, right here as I try to fix lighting and get everything nice and neat right here? I think that's got it. It's the best we're going to do. I'm just going to hit every button again. Maybe that's good. I don't know. Whoops. Going to the wrong thing. So that's got why do we use transformations. Transformations can help us fix models, make them look better. And I think what we should do, can you go over question 1 on chapter 8? Of course. Is that the homework, Abigail? And Abigail, great job right there. Abigail, I'm throwing some 500 points. You're 201, correct? Thank you for joining in on some 320 discussion right here. And as Brian fixes his lights. But no, I appreciate it. Like people, if it wants you to raise the y to the -2, let's say, would you need to log that or can you just manually raise it? You can just raise it to the -2. So if you wanted to raise y to the -2, you would just go right here and do the following. Like if it says raise this to the, like the 2, you're saying, you didn't say negative. Oh, you said -2. I always like to put it, you don't have to, but I would do that right there. Does that make sense? So now y has been raised to the 2. And if you wanted to do like x to a certain power, you could do x right here to, let's say, x said to the -3. And then you could plot this and take a look at it. Let's visualize what it looks like. Ooh, that made it worse probably. So that right there is how we could raise it to certain powers. Does that make sense right there, Robbie? We'll do some question 1 on chapter 8. It's the homework, right, Abigail? We'll do I think it's the ceramics one, right? So we'll do the ceramics. Oh, you're welcome, Robbie. Robbie, thank you so much. Robbie, let's throw out another 500 points. Robbie, I appreciate you being here. Seems like you're working on the take home. Great work. Good questions, because you didn't... I like those questions. I like the way you asked them, especially now maybe you're seeing like, okay, I take this, raise it to this, do this. I think it kind of walks through how to do it. So maybe we need to talk about like, let's say right here, transformations, take home help. I think this would give someone enough information to figure out how to do the take home. It's about 3-month bonds. You got it. Let's go check that out here. Let's get started on it. Excellent work, everybody. There we go. I think I fixed that. Wow, I was like burning up yesterday or something. I don't know. Let's go back over here. Let's go into some 320 or 201. We're doing 201. Going over to my Pearson right now. It's time for some My Pearson. About 3-month bonds. I think we're doing more regression. So if you saw Abigail right there, we are practicing regression in both classes. We get to do some more advanced stuff in 320, as you can see. But the concepts remain the same. We're talking about outliers. We're talking about plot thickening. It fans out. It fans out is the perfect answer. We want to have the same thickness. So your answer was excellent. So a lot of good practice. And the tool and knowledge comes a lot into play. And we're getting the assignment going here. So here we go. We are currently at, need to grab the timestamp on this. Timestamping live during lectures was the best idea we ever had. Stat 201. Assignment. Oh, wait. Chapter 8. 3-month bonds. Okay. Let's go check this out. We thought it was our class. Nice job, Abigail. How about it with the main screen? I like that. Like, wait, is this 201? No, it's not. Oh, wait, it's 320. So here we go. Let's start off some 3-month bonds right here. Now, it's important to know what this output is showing us. You know what's really interesting about this? This output right there where it says intercept and then it says year is exactly what we were looking at just seconds ago over here. Because Abigail, can you tell me, don't worry about the scientific notation on it, but take a moment right here, look at this output, which is just like jump output, and tell me what the value of the intercept is for this model. So just put in the first few numbers. I know it's in scientific, so it'd be 0.00000000000. I think I did enough. Maybe need one more. But what would it be? Just tell me the value of the intercept. And it's just important to know that this is telling you the value of B0. So this is what B0 is. Where do you see it in this output? You can just tell me the number as is. Which one, where is that? 100 points, Abigail. Oh, you might be talking about the problem. I think you're talking about the problem. In this one right here, this is the value of the intercept with the scientific notation. This is the value of the intercept right here. So that would be the value of the intercept, and this would be the value of the slope coefficient. Now, this model has ridiculously small numbers. I'm going to make it look just normal for a second so we can see an actual intercept and actual slope. Here you go. The value of the intercept is negative 81,000 right now, and the value of the slope is 158. And these are the values you're seeing on the screen right here. Does that make sense when I say it like this? This is the estimate of the intercept. This is the estimate of the slope. And for 201 especially, we would need to know to call these values what and what. So going in order, the intercept is called what, and the slope is called what. Like going in order of the names we use for them, the intercept in notation is called this, and I'll put some hints on the screen right here, and the slope is called this. Going in order with the names we call them. This is good review of like, what do we call these things? B0 and B, boom. There you go. Great job, Abigail. That's good practice. So that's B0 and B1. And so this is B0 right here, and this is B1 right here. And so we would plug in, and we're predicting, I think, interest or mortgage rates. The name of the Y variable is rate. The little hat on it means predicted rate, or, hey, Cora, great to see you here. That means predicted rate. And so I'm going to abbreviate 0.25 plus 0.26 is a bad idea. And we'll say years. Just because I'm running out of space. Oh, you can't even see it, so let's move it over. So there is the regression equation. I do suggest carrying all decimals at all times. You'll see me do that when I solve it. I'll type in the decimals. But we now have the values on the screen. I think the first thing might be given to us. It says, what is the correlation? Now, here's the two-step process to finding correlation. Whenever you find correlation, you must first do what to R squared. Now, there's 2 steps. Don't forget the 2 steps. Write these down. Okay, finding correlation from R squared. 1, the obvious one that everyone gets right usually, is to what R squared? I'll tell you the second one next. So what do we do to R squared to find correlation? So to find correlation from R squared, what do we do? To find correlation from R squared, we're going to take R squared as a decimal. So there's R squared as a decimal, and that's R squared. Remember, correlation is R. So it's kind of testing your knowledge here to know that correlation is R. So we want R. I'm working on the midterm right now, and I've got some. Can you send me it, Cora? Can you send me it? We could look at that next year. We don't have anything next. I think I can, because that's 475, right? So if you send it to me on Discord or email it to me, I could take a look. I'm going to say a look right. I think because you might not be in a Tisble format. Might not be in a Tisble. So yeah, send it to me, and we'll look at some trend data right here. And so, because I think Spanbauer has some stuff, especially that we're working on. Awesome, Cora. Thank you so much. We'll look at that next right here. So what do we do to R squared to turn it into R? And so I think it's R squared. And so if we want to make it into R, we have to. So we're going to take that value right there of R squared and turn it into correlation, which is R. So make sure you know correlation is R. Boom, Abigail, another 100 points. Find the square root of it. You got it. And so this is the square root of it. And then you look at the sign. You say, does it go up or down? You can tell that by the slope it goes up, or you can just look at the graphic if one is provided to tell it goes up. So we know it's positive. It could be negative if it goes down, but this one doesn't. So it's going to be positive. And we're going to go right here to 2 decimals. And it's going to round up to this. So we should get that one. Good job. We got it. On average, the interest rates during this period, they increased. Positive slope. Great job, Abigail. And at about this, so that's the slope, and it wants to 2 decimals, starting at an interest rate of this, that's the intercept. So it's saying they're increasing at about this rate per year with a starting point of 0.25. Was that an interest rate at one point? In what was it, 1982 or something? 1950? Interest rate of that? Whatever. It's pretty crazy. What does the model predict for an interest rate in 2010? So we have to know when 2010 is. 2010 is how many years after 1950. 2010 would be how many years after 1950. So 2010 would be how many years after 1950. So if we have the year 2010, that would be this many years after 1950. And we're just going to take and plug it into the equation right here that we wrote, which I think it says round to nearest integer, so we'll be fine. We can actually do this one without rounding. Great job, Abigail, right there, 60 years. So we're just going to plug 60 in. And since this one says round to nearest integer, we're actually pretty safe to use like non-rounded numbers. So we're just going to take 60, plug it into the equation, times it by the 0.26, and then add to it the 0.25. And luckily, we're very close to 16. I wouldn't usually round them, but it says round to nearest integer, which is a very like large distance to cover. So we're good. Would you expect the model to be accurate? And here's the thing we need to remember at all times. What are we doing? So let me make it kind of clear right here. I'm going to take a picture of this, and I'll show you what we're doing visually. Visually speaking, we are taking our model, and we're going, and so Cora should know this. We have a fancy word called forecasting for it, Cora. And so we're going and saying, let's make a prediction over here. And let me put a red line right here. This is where our data ends. And so let me put this right here. And what have we done right here? We've what from our model, which we call forecasting, which is a very long forecast. This would probably not be accurate. And Cora might know that we would want to use the high-low intervals right here. We might see as something like that right there for the model, because we could get prediction intervals, 8 and 95% confidence intervals on this. But which is funny, we're just looking at that in 320, and it's also in 475, and it's also in 201. But this is definitely a what of the model, i.e. forecast. Kind of extended. The X word is key right there. Now you can see it on the bottom answer D. The X word is key to know, Abigail, that you'd be like, oh, that's a blank of the model. So type it in the chat just for some practice, get those extra 100 points. This is definitely a what of the model, which means we're going outside the X bounds. This is the X bounds of the model, and we are well beyond the X bounds. Like we're over here in this region over here, which would be a what of our model. Like to go outside the X bounds that the data was created in or the model was created in is definitely thising your model. We would say it's forecasting the future, but it's an extrapolation. Core right there gets all the points button. It is an extrapolation, or we just say we're forecasting. We have the fancy forecast word for it in 475. So we would, in truth, be extrapolating to make these models. But that's got it. How's that looking, Abigail? Makes some more sense. Do know the keyword extrapolation, that when you go outside the X bounds of your model, you are extrapolating to a certain extent. And we'll talk about that in later classes or stuff. You can extrapolate to a certain degree. There's uncertainty with extrapolation, but extrapolation is generally something, at least in time series, you have to do, but in some areas you don't want to do. Like, you want to be very careful with extrapolation. Like, especially in time series, Cora, we try not to extrapolate too far into the future. Like, if I ask you, right now, Pepsi's at $160. What do you think Pepsi will be at the end of today? Just, you might say, well, it's at 160 now, probably around 160. You'd probably be pretty right. And you're extrapolating into the future. You're forecasting. And you'd probably be pretty close. I don't think it's going to go too crazy. But imagine I said, what do you think Pepsi will be at 100 years from now? You'd be like, is Pepsi even going to exist 100 years from now? I'm not going to be here to see it, probably. Who knows? But we would be like, I don't know. That's such an far out future that you're asking me to extrapolate to. I would have so much uncertainty. And that's what the confidence rolls do for us, is they give us a range of values. And when you get so far out from your original data point, your confidence intervals get so wide that you're basically like, I just don't even know. I don't know. It just could be anything. That's basically what statistics become if you go too far into the future. It's like, sure, whatever. It could be negative a billion or positive a billion. I'll just cover everything. Maybe it doesn't exist. Maybe there's no value. But that's got it. We'll head back to the main screen. Cora, great work. We're going to take out some 475 right here. I feel like the music's a little bit off today. You ever have one of those days where you're just like, man, I don't know. We had thunderstorms all last night, and it was keeping me awake. Let's see right here. Somebody, computer inventory. Ah! They're asking on my department's like, do you have a MacBook Air? And I'm like, no, I turned that in. I got to email them later and tell them that. Let's see here. I think, Cora, you messaged me over here. There we go, Cora. Awesome. Here we go. You've got the midterm. I'm going to try to show as little as possible. Okay, so you've got the trends. You've got the file. And I think you downloaded some of the data right here. Midterm timeline. Multi-timeline. Oh, so it looks to be part of the issue. Let me go back to core right here. So it looks to be part of the issue, core, is it looks like it says less than 1. So it's taking it as a character right now. Look at the data. G-trends. If it has a less than 1. So what it does when you do G-trends is it actually compares it to like the peak interest. And what term did you Google? Ooh, that's interesting. What term did you Google that was hot in 2011, 2016? Was this was it an election thing? Was it election stuff, Cora? What term did you Google to get your Google Trends on this? It's hot throughout 2014. So the issue with this is that it's saying less than 1. That's why it's not liking it. It's taking it as a character. So what we need to do is do an if else. Here, I can show this, I think. Let me talk about this. We did New Girl. New Girl must have. Well, let's put the timestamp on this. Oh, man. Yeah, New Girl was apparently. So the way Google Trends work is they show you comparative to the peak time. So working with Google Trends. So what I did was I looked at the data right here, the G Trends, and I sorted it by interest. And it looks like New Girl, if I had to guess, New Girl started at the end of 2011. That came from, no, this will work. The issue is that the data came in as a character because there's a less than 1, because it's so low that it's taking it as a character. Now, what we have to do is we have to change this. So we're going to write a little bit of code right here to do the following. We're going to do an if else. On the if else, we're going to go right here and go to g_trends and go to interest and go equals equals. It's less than 1. Let's just do this. Hello. Oh, wait, we need another thing. Sorry. Or, no. Good. We're good. These are the ones right here. Those are the ones. I always like to check to see if my code works. And now what we're going to do is we're going to take this if else. Instead of saying hello for that, we're just going to store 0. And if not, we're going to store the value of it. This will take the original value. Okay, so there we go. This is a character vector right here, and that's the problem. So if it was less than 1, I'm just calling it 0. It kind of makes sense. What's less than 1? 0. So I'm just going to store it as that. I'm going to take this whole if else right here. I'm going to go as numeric around it. So now, since it's all values, we can change it. How does this look, Cora? Is this making sense? My process right here. Let me show the process again. The original issue was, I should have printed the original vector, is that it had all these less than 1s, which you can see it in position 1 or 2 and 3. So there are values that register as less than 1, which turned it into a character vector. So even though this is numeric right here, it's a character because a less than symbol can't be part of a number. It's like it has to be a number to be a numeric inside of R. So to fix this, I first did a little test just to make sure my code was working. If else runs if the logical is met. So if the logical is met right here, it's going to run this code. If it's not met, it's going to run this code. That's how the if else works. I broke it apart a little bit further with the separation of my code right here to make it a little more clear. If else, run this right here, then run this. So the second time I ran it, I said, if it's less than 1, write a 0, else give the number currently there. Then this is a character vector because it kept the same class for the vector. And now down here, I put an as numeric around it. So I changed it to what I wanted, but then I had to wrap it in as numeric to make it a numeric vector. What I'm going to do lastly is I'm going to go to gtrends interests. Oh, that's right. Should I store that into it? Boom, boom. Cora, you got it. Cora, that's worth 500 points. Cora, we've been throwing out crazy points lately. You just did the next step. You got it. Yep, we're gonna overwrite. There we go. Now we're gonna take it as a tisble. Cool. There you go. That's got it. There you go, right there. No, where's my GG Plotly? Should do it. There you go. That's got it. There is, and we should be able to see like probably the new seasons of New Girl starting. What's interesting, if you look at this, there's like this diminished. I'm not trying to trash a New Girl. New Girl's a great show. Zooey Deschanel, awesome actress. But you see like probably when the new seasons are starting, and like a diminished interest. Like New Girl's super hot when it comes out, and then the next season, very hot still. Did they wait 2 years for a new season? Or interesting, the gaps right here. Maybe it's like every second season. The peak at the start of the pandemic. Oh, there is? Oh, nice. Yeah, probably like Netflix and stuff that it's starting to, you see a rise. Yeah, look at this. That's streaming in the pandemic. Had it already ended by the pandemic? I don't know when New Girl Star ended, but definitely like a pandemic sort of like, hey, let's watch New Girl. So that's pretty interesting. Yeah, that's, unusual variation that we see. I'm like gonna literally Google New Girl show right here. New Girl. My fiance loves New Girl. Here it is. Here's New Girl. Seasons 5 through 7. Oh my gosh. So I didn't know there was 7 seasons. Hey Girl by Zooey Deschanel. Really? I didn't. Oh yeah, she narrates stuff. I knew that. I knew that in the back of my head. When were the seasons? What years were the seasons? It ended in 2018. Oh my gosh, yeah. So it's weird that if we do a comparison right here, and what you could actually do is you should be able to add in. We could try to do a little fun with this. You see, here is the start of the different seasons. We should be able to add in horizontal lines to this because there's geom lines Watch this. The last season is not my favorite. Just it's Game of Thrones really set a pace for last season. That was close to Game of Thrones end time. No, Game of Thrones ended in 2019, I think, because it was like we were watching at the start of the pandemic. Woohoo! No, we were watching it while Chelsea was it ended 2018, 2019 Game of Thrones. No spoilers, of course, but wow, look at that. They really it's a lot. First aired, last aired. Shows really go into like hyper creation mode. It actually had some peaks afterwards. Let's grab some of these dates right here. I'm very interested in this, Cora. Like this is really a fun thing to do, is like working with these trends right here and looking at it. Let's take the auto plot and let's go to plus geom line, geom H line. No, we wanted this line, we want a vertical line. Okay, geom V line. I always get this wrong. Let's try a date. Nope. Geom V line with date. Okay, here we go. So we're trying to do this right here. We're trying to. Does this make sense? What I want to add to this, Cora? I want to add to it the different seasons of New Girl when they were starting, so we can kind of put some context to maybe some peaks. And so Stack Overflow is everyone's best friend. Ooh, did people reply to me? I need to look at it later. Asking some questions about some parsing data. So hopefully I get some requests. ggplot, geom line. That's why they're adding that. And then they're adding the V lines. X-intercept as numeric. They're taking 2 dates right there. They've already got the temp. Yep, awesome. They're taking from a vector in the temp data set. They're taking value 13 and 14. We'll just take a look what they got, what it looks like. Okay. Tell me if you need me to send you any of this code. I can just send you this whole thing. Okay, we're just going to make their temp data set. This Stack Overflow is so good. Okay, so then they're going here to the X, and let's just look at one. Let's just look at the vector, okay? So that's what it looks like. So we should just be able to take, and when they add the V line, okay, we'll go to plus geom V line. There it is right there, as numeric, and then they're taking the value. We'll put this to 2015 or so. We're just going to take the 1. Hopefully, cross your fingers, this does it. No! Warning. In new data. It's mad about that, isn't it? One row. NAs by coercion. What? It should. Is it getting mad about this? Okay, it's mad about that. Why does it like it with their code? We're so close. If you have questions in the chat, let me know. We're so close to getting this done. I never like printing. I just make my graphic. Temp X, take those roles as numeric. Oh, I think I know why. Because this is a date. Okay, so it's stored as a date right now. And where was the temp data created? As date. So just run an as date on it. So we need to put this inside of a as date. There you go. That's got it. The dates are stored as year, month. I don't know if that makes it. Yeah, no, we definitely working with a different format. That's, this should do it right here. It might be better. Like we could maybe find a way. I don't know. So many cool things you can do. And this just literally becomes, so we got how many seasons? We need like a color code chart for this. So now we need to get the thing on the screen right here. We need to get the dates of the New Girl seasons. Okay, so let's go over here. Let's put in all these dates. Where'd the dates? How did I lose it that easily? We should like post this. Like I should post it on Stats One Twitter or something like that'd be fun as long as you're fine with me because it was your idea. So we've got the first aired date right here, last aired. We're gonna lose it. Trying to get them both on the screen so we can see it and work with it at the same time. There we go. Now we'll be able to see it. I can send you this here, Cora. It's just going to be so the first aired like season premieres are going to be 2011 and then 09 and 20. And I think there's a lot of 09, 09, 09, 09, and then we skip one and we go to 09 here. And then January. It's just easier to like focus on a month. And April, January, February, March, April. And then let's do the dates: 20th, 25th, 17th, 16th, the 5th, 05, 20th. Oh, look at that! Look at that! A little symmetry right there. A little going back to where they started. And then the years are 2012, 2013, 2014, 2016. Wow, that's quick. That's a quick. Well, I guess they missed a year, so they were like, we need to get. And then the break, a little bit of time, and then the colors. Let's go with purple. It's a cool color. Black. We'll go with black then. Blue. Pink. Red. Violet. I don't know, spell indigo. And orange for UT. Well, why not? We'll end with a little classic FF8200. Okay, so we should have it. I usually don't write that much code without evaluating it. But we could also add things to it. But let's see how this looks now. There we go. Ah, look at that, as would expect. Look at the Google Trends on that. That's so cool. To see the hype beforehand, to see that there is a rise before the seasons come out. But 1, 2, 3, 4. That season, the pink one, a little hard to see. I might want to change that. And the time between. We could also put pandemic start, like when we call it right here. But yeah, this is so cool. This is like, just this is how we, make good graphics, communicate ideas. And what's really easy, we can just go to plus GG title, and we can say New Girl seasons, start of a New Girl season, search frequency. And that's got the title. And of course, we want to go here. And I got it up beforehand. Library GG Easy. And GG Easy. Whoops. Oh. Easy center title. There we go. Got that centered. And then we'll store this into graphic P. A lot of people do that for just graphics. I don't know why everyone loves store it as that. But then we'll go to GG Plotly. And we'll store it as P. And will I get my lines? Oh my gosh, we got it. And it looks a little bit nicer right now. So just communicating the ideas right here. So search frequency of New Girl, basically. And we do see it. Look at the return, though. The final season of New Girl had some more hype. Maybe that's why we see this like longer break between. But it's weird to me. You get like season 1 hype, season 2 not as much, season 3 hype, season 4, season 5. There is a pattern to this that every there is a time order pattern to this that you have a negative autocorrelation, I should say. So we'll talk more about that in class. But when you look at this, the first, the third, the fifth, and the 7th season have the something about the odd seasons. That's exactly what we see, is that the 2nd, the 4th, and the 6th, and and then the 6th season reached pandemic hype. That's something we I'll never say that again. But yeah, you see, we could put pandemic start right here. What we could do is I could add in some geom text. I might be able to add that pretty easily. Like it should be kind of obvious. It's like seasons 1, 2, 3, 4, 5, 6, 7, 8. I don't think the GeoMates lines have any text on them. They don't. But no, this is pretty cool. Yeah, pretty fun to do these sort of analytics. And what's also neat is New Girl has kind of remained at its current hype level after it dropped down from its season hype. It's never really dropped below. It's kind of maintained, which is really cool for like syndication, is that New Girl like never really drops below a certain level of relevancy and search history. Like after the first season, and when people were in this like lull before the new season hype began for the second season, it had the same sort of, you know, we might actually see finales right here. Like if we were to plot finale, like we could do like another line like start of season. We could actually like color code it like during the season. So that'd be interesting too, is like color code this like a region by a certain area to be like season 1 in purple. Then we could try to add a legend to it to say like season 1, 2, 3, 4, 5, 6, 7, 8. And these are just things you have to think about. Like, yeah, I don't know. We got some time here, Corey. Should we keep doing this? We can make the coolest graphic ever, and we'll post it on Twitter and be like, New Girl hype by like seasons. What else do you think? Because we could definitely do like the end of the season, and then we could try to like shade a region on it, and then we could try to add a legend. Like that's what I'm thinking to better communicate ideas here. Also, what we probably want to do too, and this is the great thing about Plotly, is we don't really need this portion of the graphic. And that's why I love Plotly right here. I might include that because it's got a date on it, or I might just delete the data at the start of this. Something, oh, you're saying, yeah, that's, so you might, this would be better right here. We might go to start of 2011. So where's that in the data set? I vote, yeah, I know, I too, we're not doing much. I mean, we're just chilling out. I love data. This is the fun to me. So let's see right here. I'm going to first off delete the trends before 2011 because there was no New Girl hype before then. So we're going to go here to the G trends. No, we're just chilling. If someone else has we'll hop questions if someone has it, but I agree with you. We're going to filter, and we're filtering the data, and we want to go to, we want to go to, what is it, month? Sorry, G trends. What is it in G trends? Month. So it's as a month, and we want to say year of month. There we go. Is greater than or equal to 2011. I think we've done it. I think I've got it right there. Okay, let's do something we shouldn't do. Let's overwrite our data. Haha. Or let's start as G-trends 2, just in case, so we don't have an undo on that. All right, so now we're taking and making a G-trends 2 just in case we break something, and the answer is we did not break it. So now we have a better graphic here, showing us kind of a more concise view, because prior to 2011, and I wish it would put 2011 on here because that's when it starts. Well, can't win everything. I wish it would just plot 2011. I could probably rewrite the axis, but I wish I could just double click and say, put 2011 on there. But this is the start of it. And I believe, yeah, you can tell it's in late 2011. And the intercept is not, it does have a hover thing, but I don't like that the intercept, we could work on that. That's going to be, I'm trying to think what code does that, but I wish the intercept showed you because that'd be kind of neat right there. Let's see. So we're going to try to like let's try to see if we can shade one region, like do the season 1 area. Okay. So we're going to try to shade a region, shade between 2 lines. Okay. Shade between 2 lines, shade region between 2 lines with ggplot. Okay. So they're trying to do that. That's not too vertical. Here we go. Annotate, react, geom point. It might be even easier to use annotate for this. If you know the coordinates for which region you want to shade, I had some plot. React. Annotate rectangle. Here we go, rectangle. So we're going to make a rectangle on it, and it's got the X min, X max, Y min, max, and the alpha level, and it should have like a color. So we can make a rectangle. We're going to annotate a rectangle, and then we can just do it via the color. Okay, so let's go and trying to see we're at the end of this. Okay, there's our graphic. Let's add a rectangle, and it's mad. Of course, it's mad. Cannot use GG with a single argument. Did you accidentally put plus? Oh, plus plus. There we go. Okay, so I think my rectangle's there. It's just so tiny you can't see it. X min, X max 300. We're just kind of doing proof of concept right now to see if it works. It's probably down there somewhere we can't see it. Alpha 0.8. There we go. Okay, so this is proof of concept right here, Cora, that it works. We're going to take the X values and the Y values. I don't think we need the Y coordinates. Let's see if it's probably going to get mad. It is mad, so we do need to go for the full set of Y values. And so that we're actually going to have to extend off the plot, I believe, to might give a problem. It might start shading in areas we don't want. Then we might have to set the axes. Yeah, you see it's going to do that. So let's just go from 0 to 100. And there's that. And let's say color. Should have a color equals purple. It does do that. Oh. Well, wait a minute. If this is... We might even be able to add text on it. Can we do a text? Does it have options for text? It got mad. Add text to animate. Well, it says rec. That's the name of it. Oh my gosh, Cora, we might have figured out something really good here. I can't find. Oh yeah, this is not the name of it. Okay. Let me see what the ggplotly. Trace 8. So give animation name. We just want to give that a name. So give name to annotate in Plotly. Or change hover text. Hover text in format with Plotly. Annotate hover text in our Plotly. So close, Cora. I might need to look at annotate. Let me look at annotate right here to see if it has it. We're just so close to exactly what we want. Remove. Label. Label. Oh my gosh. Unknown parameter label? It just said it. Was it labels? Label. Am I going crazy? Am I going mad? Annotate. Oh, might not be for that. Hey, what's up, Snea? So good to see you here. Congratulations on everything. I was reading some awesome emails and stuff. I'm going to be sending a video for the April 22nd event. Oh, it looks like you can only do that with the text. We're trying to make, so we're doing a graphic for New Girl right now, Snea, and I'm trying to get the annotate to change what it's called, because we almost have a graphic where we're going to plot every season of New Girl, and it's like peak Google Trends, and I'm going to make each season. Yeah, no, congratulations to you. That's excellent. Because, and the X-Min X Max, so we should be able to go in here is do the as numeric and go here to the X-Min. Oh, this is crazy. There's the X-Min. And then I forgot one parentheses. One parentheses. And now it'll go away. Go away. And then the X max right here. And then we'll add the extra parentheses. And the season, that season ended on May 8th, 2012. So May 8th, that's the 5th month. 2012. And there it is right there. So now it should put that box over there on that. And there it is right there. So we've added in. And now I'm trying to make right now, Snea, the text or the hover, and it's going to get mad and be like, I can't plot this. I'll be like, come on. Sometimes the viewer gets mad with the window size. I don't understand. But what I want now, and we're going to change the alpha probably on that, but I'd love it if we hover over it and it doesn't say trace 8, it says season 1. And we probably want to lower the alpha to like 0.2. The tooltip? Yeah, we were doing that like so what suggestions do you have, Snea? Like I want to shade the inside of it too. But the color's only shading the outside border. Yeah, the tooltip is super picky. Yeah, it is. We looked at that earlier. Because I hover over and it says trace 8. So let me Google again. Change annotate rect trace in Plotly. Okay. It's gonna call it a trace. But I don't want to call it a trace. Trace. Let me go to the bottom where maybe they do some more advanced stuff and they don't call it trace. They call it like, oh, they don't even, doesn't have hover abilities. Wait. No, why? We're so close. Some of the functions later, what did you put into tooltip? Yeah, exactly. I've done that a bit. And like, we're so close to what we want. And like, that doesn't even have any hover ability. We're so, fill color. Okay, fill color might help us with the fill color right here. So if we go to fill color, it doesn't like fill color. We're just having fun with graphics. Fig add shape. Okay, this might be better right here. We might want to do fig. Oh, is this my inside of Python? Am I doing Python? That just hurts me right there. That's sad right there. I was like, something doesn't look right. Something's not right. These codes, I don't know these codes. It's like it's in Python. Plotly in R. Plotly in Python stars JavaScript. Ruins my day. Where's the shapes? Can I search this? Pricing? How much you want to pay for it? Let's hear. Search. Rectangle. Here we go. Okay. We're going to figure this out. There's a rectangle. Look at that rectangle. Pretty rectangle. Oh, see, look at there's the shaded regions we're doing. Plot background. Ooh, plot background color. But, yeah, we might want to do that. No, it's a layout. We need to change the layout. Okay. Anything complicated is worth it. Oh, wait. They're adding the text right there, but they're probably doing it as like another text. So they're okay. Layout, legends, list, shapes, fill color equals green, line equals list, color equals green. That's they're doing. Where's the decline at? Decline text. Okay, wait. Shapes. Okay. We probably need to do this right here. Oh, and then look. Well, no, that's by company though. Layout, legends equals list, title equals list. I don't know what I mean. Shapes. One thing I've learned in 479 is hard to get nice graphics. Yeah, it can really be. I wish we could just like draw it and then R would be like, is this the code you want? Like, yes, that's the code we want. Add text, show legend. Is that how we're taking the legend text? Decline. Oh, there's the decline. Then they're adding the baseline. Oh my gosh. Doing a lot of regions is going to be painful. We need a nice graphics for our presentation. Yeah. Yeah, you could. Tableau is excellent. I support Tableau. Like Tableau makes it a lot easier. Like R can do graphics, and I love doing graphics inside of R. But you know, if we want to make something that looks really nice right here, it can take a little while. It can, you know, if we're trying to shade this in by certain time frames, like we have our graphic kind of the way we want it right now. Like, but if we want to make this even cooler, I want to make it so it shades in the regions by like their time frames, and we probably need to edit. Like this is all the intercept stuff. I'm gonna remove the. So what we have right now is we've created the following graphic right here, which shows the kind of different starts to seasons. What we should be able to do, let me add in a legend right here. So these lines right here I want to do by a different, like, let me add in a legend, because we should be able to do a legend. Like, legend equals list, and there's the list right there. Layout legend equals, let's see this. It's gonna be a horrible idea. They're piping it through, so they're piping their figure through. So they've created a figure with everything piped through. They're adding the traces, and then we would need to pipe this into it. So the proper thing to do now that we have our graphic is apparently to pipe it into this. And we have right here, what's it mad about? Open bracket. Okay. And we don't have the legend equals list, title equals list, text equals company. Oh, we don't even have the legend stuff. It's probably just gonna get mad. Yeah. Apply to class of object. It's all mad. Let's say add custom legend to ggplot. So add custom legend to ggplot. Okay, here we go right here. Use the, so there they're adding it. And legend position, go add. ggplot, geom, scale continuous. That's going to do the color right there. Might not be what we want. Okay, they're doing it right here. Let's see. If you have questions, let me know. I'm just kind of scale, color, manual, and name. Okay, wait. Let's try that. Just sure. Sometimes the best thing to do is just add on to something. You never know what's going to happen. Oh, didn't break it. Not getting it. That's the colors. Someone said, I think it's not easy or something. Not a moment. Man, people on Stack Overflow are awesome. They're doing similar stuff to us right here. Let me throw out some more points, Cora. I mean, Snea. Theme legend equals spacing and margin text. Okay. Okay, so they got this. Let's try this. Okay, let's add the classic theme, see how this looks. This might be something. This might get us somewhere. There's nothing better than solving code. And you have to have code that's not working. Okay, it's mad about it right now. Use method margin. It's mad about this, is it? Cool. There we go. The classic theme legend position equals this. Okay, that worked. I don't think it changed the graphic. That worked. It's mad about the legend. Oh, it's mad about margin? Do we not have that code? The class double numeric. Margin. I never used the argument margin. Let's see. I know Stack Overflow is the #1 thing. It's right now. I'm just like looking at my screen a whole bunch. Thank you, Snap, for being here. Another 100 points. It's nice to kind of like, I don't know. When we get this working, I'm gonna be so excited. Because it'll be just neat to have something like a really cool visualization that we're gonna probably post it. We got like 17 more minutes, so I just find these things to be fun. When it works, it's like yes, like we are gonna get this working. GG text. I need to use that. There's no package called GG text. Well, you know what that means. Install.packages GG text. It's when the first time someone hits this error, they're like, wait, what do I do if it says there's no package? And then it's like, oh, you just install it. It says no package, you install it. And let's see right here. It's still probably mad at me. Okay, it says no applicable method for margin applied to class, double or numeric. It's really mad about that. Well, why did they post broken code? You can never have too many packages. Load them all in if you could. Well, their code's not working. Margin. Okay. Okay, wait. This person did the same thing. They did it a lot smaller though. Legend bottom, legend key width, units 20 points. Where's points at? Trying to figure out how it's creating it. And let's do this. Drop their code in. Still not getting a legend. Legend position bottom. So they might have a legend to start in their graphic. And green. So much right here. Grade, error, sums of squared. Oh, that's interesting. Nice graphic. So, the legend. See where it's grabbing those. Okay. There we go. This seems even better. Theme, axis title. Let's see where they say line 1. Okay. Color. Okay. Okay, wait. Color equals line 1. Oh, nice. Okay, here we go. Okay. Now we're on to something. We've got 14 more minutes and this might actually do it. So we need to go here to calls. All right. This is good. This is making sense why we would do it. So this probably will fix our goal. And we need to add this aesthetic to it. Okay, and we're just gonna do some quick lines right here. 5, 6 seasons. No, wait, 1, 2, 3, 7 seasons. Of course, we can call it season 1. I wish it would copy that whole thing. Season 1, 2, 3, and we'll call it calls. We're going to basically copy their code. This seems very on track to what we want to do. Okay. Now we're just going to change the color a little bit here for starters. This is hexadecimal color coding. We'll just do I need more numbers. So it's how much red, how much green, how much blue do you want? So that's the red being adjusted. That's the green, and that's the blue. So we're just going to get some random colors right here. And so this will store those. That right here is a vector. Cool, a named vector. We're good. And so now let's see their code again. They're going right here. And when they make their geom line, which we're doing a V line, they're saying color is equal to this. So they're saying the color equal to that. And so now scale manual, here it is, scale manual. I need to grab all the scale manual. We'll grab the end of this code right here because that's where it's probably doing it all. Okay, so now we need to say the colors of this is going to be equal to calls 1. And that did change the color, I think, from it. Yeah, notice how the color changes of that. And then this will be calls 2. Let me take the code I have. There's the code we just copied. We'll take a look at that in a second. And we're just going to copy this. This is going to be calls 3, 4, 5. Don't worry about adjusting colors. Let's get it to work first. So now 3, 4, 5, 6, 7. Run the code. It works. Not bad color choices. Try to go farther apart from each other. But there's our colors right there. And so we're going to delete off. We're going to remove theme classic for the moment. It's nice. So I'll keep it on here. Kind of nice. Theme classic actually might be better in my view. Now we're going to go to the scale manual. Get that working on here. I mean, they should have hit enter on their code. Get the next line right there. Scale manual name equals arrow bars, values equals colors. So we are going to give it a name and say seasons. Come on. Didn't show up. Scale fill manual name equals colors, name equals bar. Sure, why not? Y lab, X lab, theme black and white, theme axis. Now, why is it not showing up? Scale color manual. Let me run through a plotly now. We are so close. We are so close to getting this working. Got 10 minutes, and it feels like it's close because we've got the colors the way we want it, and all we need to do now is I just want to add in the axis thing and scale fill manual name bar. It'd be so cool, so cool. Let me look at theirs. Well, they've added in 2 right here. So their second one is for that bar right there. And the name of it is the name over top of it because they named theirs error bars. And then they had the values equals to colors. And ggplot. So close now. We're so close. Oh, I did something similar here. Name error bars, values equals this. Did I make a mistake in their code? So close. Because it's got the colors. Values equals colors. Guide equals blue. Now, why did they have a legend and I don't? Do I need to do a geom line instead? A group? No. Might need to be group aesthetic. Yeah, it's a group aesthetic. I think that's the issue. Is I wonder if I can have a group equals. So they made a different way right here. So we need to maybe if I can throw in a group on this. Okay, it didn't get mad. Color equals. Did I spell it the British way? I did spell it the British way. Aesthetic. So it needs to have the aesthetic, I think, is the issue. So we probably need to take and redo it as a geom line. And okay. So we're going to do a geom line. I think that's probably the issue. Okay, so let's redo this one as a geom line. And the geom line, what do they store as B? Y equals B. Oh, it's the value. Let's store the dates as a vector. I should have stored that. So let's see. B is a vector. Geom line. Okay, so that's their first line. So they just drawing the line for them. So and it's doing it over different groups. It's going to cause a problem because we're not making a geom line, we're making a vertical line. Well, could we add the aesthetic to it? Could we just take ours and just do it via with an aesthetic instead? We could just add the aesthetic. So close. This is Brian's fun time right here, office hours. As numeric x-intercept. So could I just go aesthetic on this? It's mad about it. GeoMV line ignoring mapping because x-intercept was provided. A warning. It's a warning. Okay, we like warnings. Warnings are fine. GeoMV line ignoring mapping because x-intercept was... Okay. So with the aesthetic, let's remove the x-intercept and see what happens to this. It's super mad. Aesthetics. Okay, cool. Okay, so I think I understand now. We're going to take the aesthetic here, bring the aesthetic over to here, and take this info, the x-intercept right here. It's got one too many no, that's good. And we're going to take the aesthetic and put it here on the line as follows. You would think it would It's in group 1. Let me look at how they did their stack elsewise. Wrong plot. Oh no, man, time flies. Time completely flies. Aesthetic, there's so we're doing it group 1. The color is not in the aesthetic. So let me double check. Color's not in the aesthetic. And we don't have color in our aesthetic. So we do have the group 1 though. So maybe it's not doing it because we don't have enough group. So we can take this right here. Take group 1 off all this at the end. We got seconds to go. Will we get it? No one knows. And here's our code at the start of this. And we're opening up an aesthetic, so we need to close it. That's good right there. We'll just add an extra parentheses. It'll be mad. And then look at all the rainbows. Nope. And we almost got everything good. Go away, go away. Not mad yet. And I don't think it did it. Maybe. I think we're super close. So we've got the group. Add legend by group in ggplotly. Let's see here, just a moment. Okay, they have it right here with the error vars, scale manual. I think that would work. You need to map attributes to aesthetics. Colors within the aesthetic statement. Well, wait a minute, they're outside the aesthetics. Aesthetic, ggplot data equal data, aesthetic x equals a. Wait, a. Oh, there it is right there. Oh. So at the first ggplot, autoplot's going to cause a problem right here. We have aesthetics right there. Add aesthetic to autoplot. Ah, so close. Literally, the answer is we might not need. Maybe shouldn't be using autoplot. So autoplot. Okay. This is why I should not like I shouldn't use the code online. I should practice because this gets me like lazy right here. So X is month and Y is interest. Okay, so we don't have it anymore. That's fine. Where'd my data go? Month and interest. What happened? Oh, it's outside the vector of it. mad about? It's doing month as a crazy thing. Well, we will have to check this out. We're so close to getting what we want. We're so close, but we're so far. So close, but so far. And just so close. There we go. Do we have the... I sadly love this stuff too much. Well, we'll check this out later. We're going to head off. We'll be doing some classroom a little bit, but so close, but so far. We'll figure it out. Anyways, I will see everyone later. Bye for now, everyone. Bye. Office hours, Brian, trying to figure out a problem. Bye.